The last section we're looking at here, the last 2 pages kind of go together, will feel a little bit like what we were doing back in the beginning of the chapter. This is going to feel a lot like that second problem on your quiz yesterday, where you have to draw the picture of what's going on here. The only thing you have to be careful with is which quadrants you're in. Sine, we're only worried about first and fourth quadrant. If it's cosine that you're dealing with, we're really focused on the inside function first. If it's cosine that's the inside function, you want to stay in the first and second quadrant. So for sine, if the sine is 3 over 5, it's positive. Sine is going to be positive in the first quadrant. So you're going to draw the triangle in. You're going to put the angle in, because that's really what sine -1 is it's the angle. And you're going to fill in the values in the right spot. I know sine is O over H, opposite over hypotenuse. So the 5 is going to go opposite of theta, and the hypotenuse is going to be 13. What happens then, what this changes to now, what we're looking for, is we're looking for the cotangent of that angle. The inside functions help me set up where the numbers are going to go, and then the answer to that would be the angle. So then the outside function tells me what I want to find. I want to find the cotangent of that angle. To find the cotangent of that angle, the first thing I have to find is the adjacent side, yes? A little Pythagorean theorem. 5 squared plus x squared has to equal 13 squared. 25 plus x squared has to equal 169. Subtract, that's 144, take the square root. 12. And then we're just answering the question. Cotangent is going to be, so, choshakao, A over O. Adjacent is 12. Opposite is 5. That's your answer. 12 over 5. You still do need to be careful about if you go down or to the left, you have to put a negative in. But these were in quadrant 1 because sine was positive, and the only place that sine is positive, if we're looking at 1 and 4 as our choices, is 1. Does that make sense? Good? For number 2, it's cosine. Whenever you're doing cosine, we're worried about the first and second quadrants with cosine. I'm actually going to write that back in for sine. Sine, it's first and fourth. Tangent is also first and fourth. But cosine, we want to graph in either the first or second quadrant. So if we want to be negative, where is cosine negative? In the first quadrant or in the second quadrant? In the second. So you're going to graph cosine -1 over here in the second quadrant. There's theta. Theta's always at the origin. And then we have to plug this in. Cosine is adjacent over hypotenuse. Well, if one of those has to be negative, which one's going to be negative? The 1, because the hypotenuse can't be negative. So it's -1 and 3. And it should make sense that the 1 is negative because we went left, right? And then we have to find the missing side and answer the question. So see if you can work through that. So we would do the Pythagorean theorem. The one thing I would make sure to simplify here is simplify the square root of 8. That's just the one thing I saw walking around. I'd make it 2 radical 2. So then that's your opposite side. That's supposed to be 2. That's your opposite side. So then if I want to find the outside function, the cosine of the angle, or sorry, not cosine, the cosecant of the angle. I need to wake up. Cosecant is cho, hypotenuse over opposite, so it's going to be 3 over 2 radical 2, which I then have to rationalize. You get 3 radical 2 over, just be careful when you rationalize this, the radical 2's make 2, but then you got to multiply it by the outside 2, so it should be 4. Good? Questions? So the directions sound kind of complicated. It says use a right triangle to write each expression as an algebraic expression. Assume that x is positive in the domain of each given inverse trigonometric function. Blah, 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 blah. You're just doing The same thing we just did, but with variables. So the focus is on the inside function first. I'm going to set up a triangle, and we're assuming everything's positive, so we're going to keep it in the first quadrant, where tangent inverse, the inverse of tangent ends up being x. So tangent is what over what? It's opposite over adjacent. Theta's here. This is technically x over what? It's technically x over 1. So that's the first thing you have to do, is you have to write that as a fraction so that you can put each part in its respective spot. X then is going to go on the opposite side, and the adjacent side is going to be 1. And then you have to find the hypotenuse. So I'm going to call it y, because we don't want to call it x. We already have an x in the problem. I'm going to call it y. Your book calls it like alpha or something like that. I'm going to call it y because you're used to solving for y, so that's what I'm going to write. X squared plus 1 squared equals y squared. You still have to do the Pythagorean theorem here. And your goal then is to figure out what y would equal, get y by itself. So what do I need to do algebraically? Well, actually, let me simplify this side. X squared plus 1 equals y squared. What do I need to do algebraically to get y by itself? Take the square root. So that side is going to equal the square root of x squared plus 1. That is what we want to use to find the answer for that outside function. I want to find now secant of the angle, now that I got everything set up by what the inside function told me. Secant of the angle. Secant is chosha, hypotenuse over adjacent. So the hypotenuse is radical x squared over, plus 1 over, the adjacent is? The adjacent side is 1. So it's really just the square root of x squared plus 1. So they're going to look weird in this section. They're going to look very algebra-y. But that's the whole idea with this section, is we're dealing with variables more and not with numbers. This is preparing you to eventually be able to do some crazy stuff in calculus. Because the majority of you in here, when you go to college, are going to have to take calculus. So see what you can do with number 2. So I'm going to draw in the triangle to jumpstart some of you that are stuck here. So in the triangle, again, I'm making this 2x over 1 for the cosine, and cosine is adjacent over hypotenuse. So the adjacent side is 2x, and the hypotenuse is 1. Make sure you always write that as a fraction, so that way you have 2 numbers there, you know what your adjacent and your hypotenuse is. So I think most of you are looking pretty good here. So you need to find y. So your setup should be 2x squared plus y squared equal to 1 squared. Again, I would strongly, if there's more than one thing, put it in parentheses because you have to square both parts of that 2x. It should change into 4x squared plus y squared equal to 1. And then the goal is to get y by itself. So the next step is to subtract the 4x squared to the other side, 1 minus 4x squared. And then the last step is to take the square root. So you get y is equal to the square root of 1 minus 4x squared. And then we need to find the sine of theta. Sine of theta is going to be opposite over hypotenuse. So the opposite side, theta is right there. Opposite side is what we got for y. So there's square root of 1 minus 4x squared over the hypotenuse is 1. So both of these, the denominator end up being 1, but sometimes the denominator could end up being x. If the denominator ends up being x, that's fine too. You'll just have a more complicated expression. So I could have asked for I wouldn't really ask for the cosine there, but it could end up being something with a 2x on the bottom. That's fine. You can have that. Questions? We good?